It's 4 o'clock. Thank you very much. Good afternoon. And so my name is Massimo Banzi. I'm the co-founder of Arduino. Thank you for being here. People even standing. I'm very honored by the fact that you're going to stand through the presentation. And so the title of this talk is a bit of a provocation, obviously, but we live in a world where you have to provoke the audience, before, otherwise they don't click on the article. So the fact that people are standing, it means that someone got, intrigued, to just say intrigued. So yeah, everybody knows, I think a lot of you know that I'm the co-founder of Arduino. I guess most of you know what Arduino is. Okay, good. So we can save the first half an hour of the presentation, so we can scrap the first 75 slides. No, I'm joking. But I think so one of the things I wanted to do a little bit was to show that Arduino is evolving a lot. So it started off as one thing. It went through a number of different changes, and now it's taking a new direction that, to me, it's extremely exciting because it kind of closes the loop with where I started from. I studied, so in high school, I studied electrical engineering with a focus on industrial automation. So for me now that I am a very old fart to finally start to work on the things that I liked when I was a kid, because when I go to a factory, for me, it's like going to Disneyland. When I see the machine doing things, for me is, So Arduino started off in a bit of a strange way because it started off in a design school in the northwest of Italy, where we were teaching interaction design. And the idea was, we stole the director of the school from the Royal College of Art in London, borrowed her, I would say, and we were trying to teach people how to design the products of the future. The products of the future were full of technology. You interact with them. So you have to develop a language between people and the technological objects that are around us. So one of the things that you did all the time was this. You have to design, build, test, repeat. And this is what you do a lot. So the whole idea that in order to arrive at a perfect design for something, you have to go through this process. It's quite important, especially because the test part requires you to try things with people. So my task over there was to try to teach people that are very smart, but don't have a background in electronics, how to program electronic circuits, and in particular, microcontrollers. So we went through a number of experiments, we did a number of projects, master thesis, whatever. But in the end, we kind of came to this formula, which Arduino, in its first incarnation, was essentially a simple piece of hardware. This is an 8-bit microcontroller, development tools, a teaching methodology that's based on learning by doing, as opposed to, So when I went to university, the length of the theoretical lessons were quite taxing for me because I was studying and working. So every once in a while, So I've always preferred the kind of teaching that happens when you're combining learning how to make things with actual kind of learning the theory behind it, but also building a community, which is always a complicated process, but it's incredibly rewarding and at the same incredibly frustrating. You will see later, I have a couple of screenshots that show that. So I would say this phase of Arduino as a tool for prototyping ideas I think that probably the peak Arduino, the first phase of Arduino was the chair that tweeted every time you farted. And this is a screenshot from some of those tweets. And so that was peak Arduino 1.0, I would say. But then obviously, more from a teaching tool, it started to become a tool that actually big companies, and even just in the few, short time I've been in this building, I met multiple people that told me that they used Arduino to start companies, to prototype products. So it really became something in a way encapsulated by this motto that we use sometimes, which is we try to enable anyone to innovate by making complex technologies simple to use. And this seems like a simple and kind of, basic mission. But if you think about it every day, new technologies become available in a format that we can now, they're cheap enough that we can now give them to to a large audience. No? So, for example, when I started working on electronics, we did analog electronics. So you took transistor, resistor, capacitor. It was quite complicated. Then microcontrollers became cheap and simple to use. And suddenly you could teach electronics to way more people because the software part is way easier than the analog electronics part for someone who doesn't have the background. So, and then it became IoT, and now it's like tiny machine learning. So there's a lot of different scenarios where what we do is about trying to figure out how we take a piece of these new technologies that are becoming available and make them more simple. Obviously, one of the things that happens is that Arduino started off as an open source project around 2005. It became a company more or less around 2008. So if you think about it, depending on where you look at it, is it 13 or 15, 18 years that we've been working on this thing. So you can imagine any technological project that goes on for such a long time changes shape multiple times. And so one of the things that's become one of my tasks that I do for the company is to spend time on online forums telling people that everything they know about Arduino is wrong. Because obviously one of the things that happen is that some people, they came up with an idea of Arduino at some point in their personal history and Arduino's history, and now they're stuck with that idea. No? So I'm going to dispel a couple of myths, and then I'm going to tell you a little bit more what we are doing right now. So, for example, there's a number of people that think that Arduino is a foundation. I think it's got to do with Raspberry Pi, probably, because some people compare us with Raspberry Pi and, whatever. But Arduino is not a foundation. Arduino is a company that also manages an open source project. And if you look at it, so Arduino, again, has been around until 2008, and these are all the different things that we did, all the different changes that we made, and also, as a company, last year we went through also an investment of around 30 million euros from different players in the market, including Bosch, Venture Capital, and a bunch of other people. So in a way, it's interesting how a lot of people somehow are kind of stuck in this area of the history of Arduino. Another thing that we get a lot as a question is like, yeah, but if I want to use your products, then what happens if you go away? What happens if you do something else? No? Well, first of all, obviously, we are open source, so technically someone else can just make most of the stuff that we do. But actually, if you look at it, some of our products, like this one, has been made for now 13 years and counting. So it's still available, it's still there. So we actually have made a commitment in a way that when a product has people who buy it and use it, we keep making it. We make stuff for many, many years. And, because we think that it's also made our life not so easy sometimes because we have quite a few products that kind of linger with us. But, people are using it, people are buying it, people are using it in a lot of different applications. We want to be there for them. There's also this other thing that some people say, but where are the products with Arduino inside? So actually, there's a lot of products. I just used a generic 3D printer as an example, but there's a lot of 3D printers that use Arduino boards. Their main board actually was one of the big things. But there's actually quite a few companies that use now Arduino boards, and I'll show you also the kind of Arduino boards they're using to power actual products. And I think this is an interesting evolution from a prototyping platform to something that is very different from a prototyping platform. Also, the other thing that's interesting is that people are kind of fixated on this. When they say, oh, it's an Arduino, they look at this. And so Arduino makes about 100 different SKUs, of which probably a good percentage of that are just development boards. So this is just one. Obviously, it's the most popular one. It has sold, so there are more than 10 million original ones in the market. And I don't know how many other millions of Chinese clones, copies, whatever, rip-offs. There's many different versions. But in a way, I'll show you later that this is just, it's just saying that, I don't know, imagine in this country that anybody thought that Ford only made the Ford Escort, and not even the current model, the one from 15 years ago. No, that would be a little bit bizarre. No, but there you go. So there's actually more coming. It's also interesting, this idea that since Arduino is open source, anything is an Arduino board. Well, effectively, I argued with this gentleman online. So there's some screenshots from Reddit, which is one of the places where when I go into battle and I come back with some bruises, but every once in a while, I even manage to convince some people. I erase the name because it doesn't make sense to quote the name of the people. It's just an example. So people say, oh, there's no thing as a fake Arduino. Actually, no. I mean, you can make a board that is made from the Arduino files. You can do whatever you want, but you should not, and you must not call it Arduino, because some people sometimes they buy this thing, which is fun. I mean, if you want to buy this, and some people sell them with the Arduino logo as well, which is really. But obviously, I think the existence of an official Arduino, it's useful for people to say, this is the reference, it's the official. If something goes wrong, I have someone I can complain with or whatever. While this thing, some of these are very, very cheap, but because also they're made with, not exactly the best parts. So some of them fail, some of them have problems. So if there was a very local example because a university in the UK actually designed and manufactured several thousand respirators, ventilators for COVID patients where it was impossible to find them. So they came to us and they bought 7,500 original Arduinos, because it's all fine when you're using this to prototype, but then when you have to attach actual people, you want something from someone that at least you trust. So I think there is a version that, I think there is this thing that not all the boards are Arduino. Another thing that's interesting that people have quoted a lot of times is that Arduino is crippled by the lack of a JTAG debugger, which is actually kind of not true. The original Arduino development environment that we created was designed essentially for students. It was very simple. We strived and fought very, very hard to keep the toolbar only to 7 buttons, which a lot of people complained, and because they wanted more buttons. So in the end, we actually redesigned the IDE, and we launched it now a few years ago. And this is the Arduino IDE 2.0. And this one is based on the same framework as Visual Studio Code, and it's capable of actual debugging. So this is a GIF taken from a debugging session done with the Arduino Zero, because the Arduino Zero has a JTAG debugger on board, but now quite a few boards have that. And yeah, you can do all the things you do with classic IDEs. You can do breakpoints, variables, you can do whatever, and you can kind of navigate through the code. So, it's interesting because people are kind of stuck to, in a way, a classic, view of the platform. So the next one is one of my favorite. Are you ready? So this is a Reddit called Don't You Know Who I Am, where normally people post screenshots of people arguing online with the creator, the founder of something, telling them that they are wrong. So this guy, it was incredible. This lasted days. It was an incredible battle. This guy said Arduino was about prototyping and prototyping only, and I tried multiple times to convince him otherwise. He wouldn't listen. He just went on and on. He was everyone was telling him, just shut up, and he would reply to every single one of them. So somebody and then he said, haha, but the creator of Arduino gave this interview that says that Arduino is for prototyping. And I said, yeah, that interview is from 13 years ago. You know what I mean? So it was very interesting because this guy wouldn't let go. And then when the screenshot was posted on Don't You Know Who I Am, this was on the Arduino Reddit. So this was he came and answered every single person on that thing. It was like super cringe. He wrote hundreds of messages. Even when people were like, oh, for the love of God, shut up, he would just respond to that. Which, So what is interesting is that when he posted this, I looked at it and I thought, oh, when did I do that interview? And then I realized it was 2010. And I thought, you know how many things have changed in 13 years? And so after that discussion, somebody posted this, like, Massimo really turned the table, didn't he? But the funny thing is that only stupid people never change their mind. You know what I mean? All the platforms, everything that you build has to evolve in time. You know what I mean? So a bunch of products we used every day started off for one purpose and they became something else because people found use for it, because it disrupted something, because people just liked it. No? So we all evolve throughout our life, and so do platforms. So this was just a silly introduction just to show you how people, mostly on online platform, they tend to have this idea that never change with time. While it's crazy for people like me, because we spend a ton of time evolving, changing, improving, going in different direction and doing different things. So in a way, the modern world, from an Arduino perspective, is based on the fact that after we developed all these products, they were mostly originally for students and then for makers. And then we actually started to develop actual products for the educational market, so for schools and all of that. We started to see this phenomena that people started to put Arduino boards in actual products. So you would see that they would use it to power small industrial automation. They would use it for machines. And we know because they wrote to us and said, I'm using an Arduino and this thing I'm doing for this big petrol company that I can't quote. And we are using this Arduino Duo to run this piece of equipment, or the U.S. Air Force using Arduinos to test some fighter. Or NASA. Somebody at NASA bought a bunch of Arduinos like the other day. So they sent us an email because, being like big government, they needed a bunch of certificates to certify the product. But it was very interesting to see how people started to use Arduino to actually build things even CERN once sent me a picture that they used an Arduino to build data loggers, and they put them in the Large Hadron Collider, thinking, when we start the collider, the magnetic field is going to burn the Arduinos, and the Arduinos survived. And they sent me a picture, and they were like, oh my God. And there was this large head and a box with all these Arduino stickers on it. And so, this was an indication that there was an evolution in the way people do embedded development, and we sort of had to kind of follow that it was interesting to follow that, because a lot of people, in a way, now they are kind of split between we define them unpleasant, but choices that you do your own design from scratch, and a lot of people that do professional stuff, sometimes they don't really have the ability to do a complex design completely from scratch, or they use system of modules, and it's great, and there's a lot of supplier over there, but one of the things that we realized people really liked about Arduino is the fact that Arduino is open source. So in a way, it's the open source software and also hardware to a certain extent is taking over all the enterprise business. Now, if you talk to someone about developing a web application and you tell them you're going to use a proprietary software, they're going to look at you and think, what? Who uses all the languages that we use to develop web applications are open source. All the frameworks that we use are open source. No? Whenever a big company develops a framework, they release it as open source because they want other people to use it. So in a way, open source is going to slowly take over the whole software market. It's kind of inevitable, I would say. And so we are, in a way, interesting. We are positioned in an interesting way because we are part of this. We are one of the first people that kind of really did this whole stack open source left and right. And so we also have, in a way, the ability to kind of sit in between a lot of the interesting work that the open source community does and some of the needs that some of the companies we work with do. So we can act as a bridge between these two worlds. Because at the end of the day, right now, Arduino does all of this. So we build hardware, and I'll show you a couple of the hardware in a second, but we build hardware that's designed and manufactured to industrial standards, to industrial temperature. So the board you see up on top, it's a system of module that uses a Cortex M7 plus a Cortex M4 processor. It's a dual-core microcontroller from STM. So it's an STM32H747 something. So it's quite powerful. Then we have development tools that now are very far away from the original Arduino. We built a lot of integrations into different cloud software, but we also build a cloud software. Obviously, the IoT cloud that we built is not designed to replace AWS, but it's designed because there's a lot of people that are professionals. They don't understand the whole stack, and they want something they can use to build something that's secure out of the box. So we built that. So we built hardware, the firmware, communication, we support different communication protocol, cloud and cloud software. So all of that is into this container that we call Arduino Pro that we launched now I think just before the pandemic. And it's really evolving a lot. So for example, we make, from the modules, we also have all the different development boards where you can put these modules on. We actually made a micro PLC. I'll show you later. It's very nice. It's using the same super powerful microcontroller. A lot of people love this now because they can run the control algorithm and also the part that kind of creates the digital twin and connects to the cloud, all in the same device. They can program it with multiple different tools, and we're trying as much as we can to embed the security in the hardware, in the software, out of the box. And also, there's quite a bit of work that we are doing on Edge AI, also with partners like, Sensimel, Edge Impulse, this kind of people. So it's a slightly different approach. It's an approach that recognizes there's a lot of people that are experts and professional in their own field, but they don't understand the rest of the stack, and they need a toolbox where they can take what they need and they can build what they need. The longevity that I touched upon, it's quite important because all the products are tested one by one in the factory, so we don't just test the sample of the products. Everything is tested and everything is given a serial number. There's a database of everything that was manufactured. We can trace back every device. 99% of what we do is made in Italy, so it's assembled in Italy, which I think it's also it's important because we can, on one hand, we have a certain level of quality, and on the other hand, we actually try to do as much as we can to manufacture in places where the impact on the environment is the least that you can have. I mean, electronics, we know it's a business that's a little bit, polluting, uses a lot of energy, but if you try to do it well, you can reduce the impact. So longevity, we also have now a team that answers people. So if somebody has a professional product, there's a team that you can write, you can call, and they can help you with the product. And as I mentioned, there's a lot of different things that we do to try to embed security in the product. We also got this PSA certification from ARM on one of our products. So we're really working quite hard to make sure that we make something that it's useful out of the box. So we have different use cases of people that use the product in manufacturing a lot. In the sort of, we work a lot with Italy and Germany that are big manufacturing countries. Industry 4.0 is a big thing. Now in the US, we have this new CHIPS Act that talks about advanced manufacturing, so we do quite a lot of work in that. Building automation, transportation, mobility, smart cities, smart agriculture. So there's quite a few of the products that we do that fits in these categories. And we worked on projects like, so we developed this thing called potential machine control, which is I would say it's kind of it's a machine controller, but it's kind of like a PLC, but not really a PLC, that's designed to run this type of equipment. So it was developed for an Italian company that makes ovens. So they can remotely run the oven, but they can also manage it, update it, do the maintenance all remotely. So this one has all the capability to measure temperatures, manage different protocols, and they use the cloud that we developed to kind of manage these devices. We also have companies that use TinyML running on a small device to actually do some kind of predictive maintenance type project on HVAC. This was a hospital network in Italy. And this was a project in Germany, if I remember correctly. So this Portenta X8 is our Linux-capable board. So, and one of the particular thing, in my opinion, about this is that it comes out of the box with the Linux operating system that's very lightweight, and it runs containers natively. So the way you deploy application on this, you just deploy a Docker container from a platform. We use a platform that was developed in the UK called Foundries.io. So we can manage the application running on a fleet of these devices from a centralized platform. So in a way, we also built this kind of process where we do innovation workshop with some companies. We spend like a couple of weeks with them, we look at what they're doing, we prototype solutions, and then with the tools, they can do like small series, and then there's a way to actually scale to products. So I'll show you quickly some of the products that I was talking about. So this one is it's a microcontroller. It's the dual-core microcontroller boards, but it supports Wi-Fi, Bluetooth, secure elements. So there's a battery management, so you can run it on a battery. So this is the building block. This format is the building block of most of the Pro products. So you'll find it inside this thing, which is the machine controller I was talking about. So this supports CAN, RS-485, a bunch of different protocols, all different temperature sensors, Wi-Fi, Bluetooth, Ethernet. So it's got a bunch of different. So this is used quite a lot by people who do industrial automation. Sometimes just to actually run like a control algorithm, and sometimes just as a sort of I/O expander for something else. We also have a nice little product. This is a 1 inch by 1 inch in size. This one it's a little board with a ton of sensors. And one of the coolest sensors it has, it's a gas sensor that can be trained to understand different smells, for example, or gases. And we actually built a nice project with this Italian/French brand called Keyway. They do jackets. So we built this jacket with this little device connected to them. And actually, we asked people to build projects. They built a lot of very cool projects, including something that would detect if a diabetic runner was in a certain particular how do you say it? Well, they were in ketosis essentially, or other different projects, all built on the idea that what happens if you have this electronics that has a lot of sensor, it's embedded, it's simple to program, and it's got Bluetooth. Same family. This one is a camera that runs a machine learning on the same processor as the other bigger boards. And it's actually running a version of MicroPython with all and you can actually train it. You can actually take pictures. You can use edge impulse to train the algorithm. You get a TensorFlow model, and you can just run it. So we built this thing, which is it's a vineyard pest monitor. So the insects go in, and effectively, this is detecting one specific type of insect, which is called Propilla japonica in this particular case, which is a pest of vineyards. And so it detects using computer vision, and then it takes a picture every few seconds or every few minutes, and then uses LoRa to send the data to the cloud. So in a way, it's designed to be a very simple way to do computer vision on the edge, low power, all enclosed, no cloud, very simple. We also have industrial customers that are using it on a production line to detect if the cap on shampoo bottles it's mounted correctly, replacing just a simple sensor with the computer vision. That one is quite popular. We also do quite a bit of work with TinyML. These are some projects done with this little kit that we developed with Harvard University. And there's a little bit of edge impulse in there as well, to to basically make it simpler for people to start with tiny machine learning. And people have built a ton of different projects in that area. The famous PLC I was talking about. So this one is using the same STM processor, all the other family. So you can program it in C++ with the Arduino framework. Without the Arduino framework, you can program it with MicroPython, and you can also program it with PLC IDE. So we partner with a company that's been developing PLC development environment for about 20 years. So this thing supports the ladder logic and all the different other structured test format that you use on PLCs, with the addition of the fact that it supports connecting to the cloud. So you have different blocks that you can use in your application that allows you to connect natively to the cloud. And this is supporting the portent machine control and the PLC. The PLC was done in partnership with this company called Finder, which has been making relays for the past 70 years, so they know how to make robust products. This is, it's available with RS-485, Ethernet, Wi-Fi, Bluetooth. So it's like less than, depending on the configuration, it can be like less than 200 euros. So in a way, there's a lot of different steps for people to be able to build these complex applications. We try to be present at every step so that we have some kind of a progression that if someone is an expert in a certain field, but they don't really know how to build this application, with our tools, they have all the tools they need to actually go from the device to the cloud. We are quite popular online. So there's actually 500,000 people on LinkedIn that list Arduino as a skill. So this means that one of the things that we found is a lot of companies like Arduino because whenever they need stuff, it's very easy to find them wherever they are. Other people are much more difficult to find. So there's almost 30 million people using the Arduino IDE. So I'm going to use a metaphor that I like a lot. And is that we try to be, whenever someone is approaching a new technology, even if they are a professional, sometimes certain technologies are, in a way, probably presented in a complex fashion. They're not very well explained. They require a lot of effort. So some people perceive it as really climbing a mountain. No? So this means that a lot of people will say, that's not for me, I don't care. So we try to build tools that are a little bit like a stair. You go to the same height, but it's one step at a time. And the idea that you have a small success, and then you go from small to small success, and you reach the top at the same time, but the amount of people that you can take to the top is way, way higher. And with the Arduino Pro, we've seen that we can actually take people who work in factories, work in agriculture, and they can design and make their own projects. They can innovate. And I think trying to build tools like this is going to enable so many more people now that we have this product that can go into the industry. And so it's going quite well, but I wanted people to understand that if you think the Arduino is still the Arduino Uno, probably almost everything you know about Arduino is wrong. Thank you.
Anyone?
Questions? Oh.
Thanks a lot for a very useful presentation. Sorry, can you expand a bit more on wearable cases for wearable devices, maybe med devices, medtech devices? So I don't know, you said Harvard done something because I'm more interested in wearable stuff, so where to use specific project there?
This particular product, it's used quite a bit in wearable type applications. So it's a small, it's 1 inch by 1 inch. It's running a Cortex M4 from ARM. So it's got a Bluetooth connection, and it comes with a ton sensor like inertial measurement unit. So it's a dyne-axis sensor and a gas sensor. So you can actually do quite interesting things. So the idea of using it in a jacket was just a way for us to kind of collaborate with this fashion company, just to go out of the usual type of application. So people use this either as a sensor node in an industrial application. So we have I think we have a demo at the booth that show how this thing mounted on a fan can detect everything that's happening to the fan just by looking at the sounds and the vibration. But but it can also be used as to do wearable applications, and it can run on a battery. So this particular device is running on a battery. So the basic demo was measuring the air quality, and then it was changing the color of the case based on the air quality. And with zero optimization on my part, it was running easily for 24 hours by doing this very, 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 very frequently. If we had done this measuring only like every 5 or 10 minutes, it probably would last for many, many days. So if you can optimize the code, this can actually run for quite a lot of time on a small battery.
And sorry, what about the one that you mentioned about Harvard, something
Oh, this is
on a hand device? Yeah.
Slightly different. So this thing is a kit that we developed based on one of our products, and it's used by Harvard University to teach machine learning, tiny machine learning. And these are some of the examples of the application that people have built with that hardware, that kit. So, for example, someone built this project that can detect if somebody is about to have an epileptic attack, just by analyzing the vibration on the arm. But here they're analyzing the sound made by some pigs to detect potential respiratory diseases. So there's a number of interesting things that can be done with a fairly simple hardware, and some of the tools like Edge Impulse, for example, that you can find here in the exhibition.
I'd like to say thank you very much for everything you've done, particularly the new cloud and the Pro. One thing which you mentioned there that I still struggle on is optimization if you want extremely low power, and that's looking at battery life, so sort of over a year. Is there something I'm missing, or is it just going in and optimizing?
Sorry, let me understand the question a little bit better. So you're talking about optimization of the code or speed of the...
It's typically not speed, it's applications, connected sensors, where I'm looking at sort of months or years running off small batteries. Mm-hmm. And that seems still to be sort of almost the magic where you need to go in and start fiddling down with the code.
So, no, it's true. So I would say most of the examples that you find online on the website, like on most of the documentation that you find for these kind of products, it's never goes into too much detail about how to optimize the power. Obviously, in order to keep the code simple, you never optimize too much. But we do have customers that are using some of the products to run. For example, we have people that are using one of our LoRa products, which is using a simple Cortex-M0 Murata LoRa module. And with the right code, they can run it for quite a long time. It's normally something that we don't publish. It's if a customer needs help, there is people who can sit down with them and kind of help them with the code. I understand we should be actually producing more content that explains how to achieve that kind of power efficiency, but we haven't done it yet. But it is possible to do it. Yeah. It's just that for simplicity's sake, we don't really show it very much. But it is important, because if you have a sensor in the middle of the forest, you don't want to go and change the batteries. Yeah.
I have the feeling that in 5 years you will do the same presentation. You say we get it wrong about Arduino. So how you see the company in 5 years? Is it going to change a lot? So what's your
interesting?
Vision?
It sounds like when you go to an interview. So where do you see yourself in 5 years? No, I think that what you see here, the Arduino Pro, is going to be slowly becoming the Arduino, clearly, because the rest of the applications, slowly, the market will change, but the Arduino Pro is an area where there is still so much to be done, and there's still a lot of applications that are still done in a very conventional way, and there are some applications that could benefit from looking at things in a different way. So I'm not saying that everybody should just take what they do and throw it away and use this, but there is a significant part of the market that could look at things in a different way, and we have tools that can help with that. And I think in 5 years it's going to be more and more pro. I think it's going to be more and more AI, clearly, because this machine learning stuff that we are doing at the edge at the moment is still quite simple. But for example, more and more people want use cases of computer vision on the edge with no cloud running on the device. So there's a bunch of work that we are doing with people to go in that direction, to expand on the things that. So we are working with a startup who is going to implant that camera in a human body. So they're going to get FDA approval. So when that happens, it's going to take years. It's probably in 5 years, I'll be here saying, we implanted the camera in the body. So I think that's the kind of task, the kind of things that we're working on, things that require years to get to. And yeah. Okay, thank you very much.